Chocolate making is such a precise and surprising process that few people imagine what really happens inside a modern factory. How do you transform a dark, bitter bean into a smooth, shiny bar that melts at the touch? And what allows brands like KitKat to achieve such a perfect, consistent finish? Today, we'll walk through every step of this transformation, from the beans arriving at the factory to their conversion into products ready to travel the world. You'll be surprised to discover how many machines, precise temperatures, and technical decisions go into creating flawless chocolate. What happens during roasting? How are the shells separated? What role does cocoa butter play? And why can conching last for hours, even days? Each answer reveals that making chocolate is much more than just mixing ingredients. It's about mastering complex engineering. Join me, because you're about to discover the inner workings of one of the most delicious processes on the planet. And when we get to the KitKat section, you'll see how technology manages to create bars with perfect layers of wafer and chocolate without losing a single detail. This journey will reveal secrets few have seen. Although the heart of the action is in the factories, it all begins long before, deep in the tropical regions, where the cacao is born and grows. This fruit from which chocolate is made comes from a tree called Theobroma cacao, which means food of the gods in Greek. And for good reason. The forests of South America and West Africa offer perfect conditions for its cultivation: constant humidity, warm temperatures, and shade filtered by taller trees. Under this natural canopy grow small flowers which, after several months, transform into thick, colorful pods resembling dinosaur eggs. Interestingly, this crop is still cultivated primarily by hand. There are no tractors or industrial harvesters. Farmers use machetes or curved knives to carefully cut the pods without damaging the tree. Each fruit is harvested individually, placed in baskets, and transported to collection points in the middle of the forest. Inside each pod are between 30 and 50 seeds covered in a sticky white pulp. These seeds, which don't yet taste like chocolate, have a bitter flavor with a hint of acidity. But this pulp is crucial for the next step. The seeds are piled on banana leaves or placed in wooden crates, and the fermentation process begins, essential for flavor development. This stage can last up to a week, during which time the seeds naturally heat up, lose their slimy coating, and change color. This biological process reduces bitterness and develops the precursors to chocolate aroma. Afterward, the seeds must be completely dried for preservation and to prevent them from spoiling during transport. Farmers spread them out in the sun on blankets or bamboo mats, and turn them several times a day for even drying. This step, though simple, is critical. If the beans are not dried properly, it can ruin the entire batch. Once the humidity level is right, the beans are packed into bags and ready for their journey. Thus begins the road to their next destination, the factories where the magic of chocolate truly begins. Although we've already briefly mentioned the fermentation process, it's worth delving deeper into this step, because without it, chocolate simply wouldn't exist as we know it. Once the seeds have been extracted from the pod, farmers place them in a basket covered with banana leaves or in wooden crates with holes to allow air circulation. Here begins a complex biochemical transformation that lasts between 5 and 7 days. Meanwhile, the white pulp surrounding the seeds decomposes through the action of natural yeast and bacteria, generating heat. This temperature increase, which can reach up to 50 degrees Celsius, kills the seed embryo and triggers internal reactions that reduce astringency and develop the precursors to chocolate flavor. The process is not static. From time to time, the beans must be turned manually to ensure even fermentation. If this is not done correctly, the final taste can be seriously affected. This phase also determines the initial color of the bean, which changes from a milky white to dark brown or deep purple tones. Once fermentation is complete, the drying stage begins. This step is crucial for stabilizing the beans, reducing their internal moisture content to safe levels, generally around 7%, and preventing mold growth during storage and transport. In many regions, drying remains entirely natural. The beans are spread out on concrete floors or woven mats and turned several times a day in direct sunlight. This process takes between 5 and 10 days, depending on the climate. In larger-scale factories or in regions with frequent rainfall, mechanical dryers are used that control temperature and airflow to maintain quality. It is during this stage that an initial visual sorting is carried out. Beans showing mold, cracks, or incomplete fermentation are removed manually. Only the best continue their journey to the factory. The result of these two steps, fermentation and drying, defines the foundation of all chocolate. The quality of the taste, aroma, and texture depends largely on what happens here. From this point on, science takes over. The seeds are ready for their journey to the facilities where the cocoa is transformed into chocolate. Once the cocoa beans are completely dry and packaged in bags, their second great journey begins, from the tropical regions of the planet to chocolate factories scattered across the globe. These sacks, which can weigh between 60 and 70 kilograms, are transported by truck to the nearest ports where they are loaded into containers and onto cargo ships. From there, they cross oceans to destinations such as Europe, Asia, or North America, depending on the brand and type of chocolate to be produced. During this journey, the beans must be kept in stable conditions to prevent moisture and spoilage. Improperly stored cocoa can absorb environmental odors, lose quality, or even develop mold. Once they arrive at their destination, they are transported by truck directly to the factories. There, before entering the production system, a detailed inspection is carried out. The size, color, moisture level, and presence of impurities are assessed. Only beans that meet the standards continue. What's curious is that the price of cocoa has increased several times since its origin. Initially, a ton might cost around $1,000. By the time it reaches the factory, its value can exceed $10,000. Now that the beans have arrived, one of the most impressive stages of the process begins, transforming these tiny fragments of fruit into a thick, glossy, and aromatic substance known as cocoa liquor. It all starts with cleaning. The beans are poured into giant hoppers where they pass through ventilation systems, magnets, and sieves that remove stones, dust, twigs, or any other impurities. Next, they are weighed, sorted by size, and briefly stored before entering production. The first major step is roasting. The beans are placed in enormous rotating drums that reach temperatures between 120 and 150 degrees Celsius. This process lasts 20 to 30 minutes, depending on the desired flavor profile. It is here that the chemical reactions take place which reduce bitterness and develop the chocolate's aroma. Furthermore, the heat softens the bean's shell, facilitating its separation. Next, the beans pass through a grinding machine where they are broken into small pieces called cocoa nibs. An air ventilation system separates the lightweight shells, leaving only the nibs, which are the most valuable part of the bean. They are filled with cocoa butter and aromatic compounds. These cocoa nibs are fed into roller or ball mills where friction and pressure transform them into a thick paste. Cocoa liquor, despite its name, does not contain alcohol. This is a dense, warm mixture with the pure, intense flavor of cocoa. It is here that a crucial decision is made. Part of the cocoa liquor is pressed to separate the cocoa butter from the remaining solid, which is then processed into cocoa powder. Butter is used to give chocolate its smoothness and shine. Powdered chocolate is used in drier recipes or to add flavor to other products. Another portion of the liqueur is mixed with ingredients such as sugar, powdered milk, or dairy solids, depending on the type of chocolate being made. Bitter, milk, or white, but it's not finished chocolate yet. What follows is the refining and conching process, where we get that fine, creamy, and perfectly balanced texture we all recognize. At this stage, the cacao has left the forest behind. It has been transformed by science and is ready to become an irresistible delicacy. During the grinding process, the temperature can exceed 70 degrees Celsius due to friction. This is intentional. This helps release the cocoa butter and allows the mixture to remain liquid. Temperature control at this stage is vital because if the mixture cools too much, it can harden and clog the equipment. Modern mills are equipped with sensors that monitor the consistency of the liquor and the amount of fat released in real time. In fact, a slight adjustment to the pressure or speed can significantly change the chocolate's profile. At this stage, the cocoa liquor has transformed into a rich base. But it still lacks the refinement that transforms a thick mixture into a smooth and perfectly balanced bar. This is where a combination of mechanical and chemical precision comes into play: refining, conching, and tempering. First, refining. The mixture of cocoa liquor, sugar, powdered milk, and other ingredients passes through a series of steel rollers that grind the solid particles. The goal is to reduce them to a size between 15 and 30 microns, small enough that the human tongue cannot detect them individually. This step is fundamental to the final texture of the chocolate. The finer the particles, the smoother the mouthfeel will be. Next, the refined mixture enters the conching machine. This is one of the longest and most crucial steps in the process. Steel blades constantly stir the mixture for between 6 and 72 hours, depending on the desired quality. As it is stirred, the heat and movement allow bitter aromas to evaporate, the fat to distribute evenly, and that rich, full-bodied flavor we all love to develop. During conching, residual moisture is also released, and the chocolate's rheological properties, namely its fluidity, are improved. If done correctly, the result is a smooth, aromatic mixture with a velvety texture. Next comes tempering, a process that is both delicate and essential. The liquid mixture is first heated to approximately 45 to 50 degrees Celsius to completely melt the cocoa butter crystals. Then, it is cooled to 27 to 28 degrees Celsius and finally gently reheated to approximately 31 to 32 degrees Celsius to stabilize the entire mixture. This precise temperature control allows the chocolate to solidify with a glossy texture, a satisfying snap when broken, and the ability to melt smoothly in the mouth. If tempering is not done correctly, the final chocolate may have white spots, a grainy texture, or a dull surface. In many factories, tempering is carried out in automated machines that adjust the temperature to the second and degree. This step prepares the chocolate for its final stage, molding and packaging. But before that, something special is missing, as is the case with KitKat. Conching is so important that many premium brands consider this step their signature. Some companies conch for over 48 hours to achieve a unique flavor profile, while others adjust the paddle speed and conch type to modify the texture. Each additional second brings a different note of sweetness, bitterness, or creaminess. Interestingly, the tempering process not only improves the chocolate's appearance and texture, but also influences its shelf life. Properly tempered chocolate keeps better and is more resistant to temperature changes. This level of precision has transformed chocolate making into a discipline as technical as watchmaking or pharmacology. Once the chocolate is perfectly refined and tempered, it's time to shape it. And in the case of KitKat, this shape is inimitable. Beyond being a chocolate bar, it's a work of food engineering with multiple layers and a highly standardized design. It all starts with the creation of the wafers. These thin layers are made from a mixture of flour, sugar, cocoa, and raising agent. They are baked into large, thin sheets, which are then cut into precise sections. Between each wafer layer is spread a specially formulated chocolate cream that not only binds the layers together, but also adds a smooth, creamy texture to the inside of the KitKat. Once assembled, the multi-layer sheets pass through a gentle press that compacts them without breaking them. Then, a high-speed guillotine cuts the block into individual bars with millimeter precision. Each bar is inspected by optical scanners that detect defects in size, thickness, or alignment. Then comes the chocolate bath. The cut bars are placed on a conveyor belt that carries them under a constant cascade of tempered chocolate. The coating covers every nook and cranny of the wafer, forming that uniform, shiny, and crisp layer. After coating, the bars pass through controlled cooling tunnels to perfectly solidify the chocolate. Finally, they are automatically packaged, boxed, and labeled for worldwide distribution. Each KitKat is the result of a precise choreography of ingredients, machinery, and quality control. And although it's mass-produced, each bar strives to maintain the same experience. It's that satisfying snap when you break it open and that unmistakable taste when you bite into it. Now that you know every step behind a chocolate bar, from tropical plantations to the robotic precision of a factory, you can see that chocolate is much more than just a craving. It's the result of traditions, technologies, and a supply chain that connects farmers, engineers, and scientists from around the world. Every bite of chocolate you enjoy carries within it a story of effort, innovation, and perfection. From natural fermentation in the forest to meticulous tempering in a high-tech factory, everything is carefully crafted to guarantee flavor, texture, and quality. And if we're talking about iconic examples, Kit 4 represents that perfect blend of industrial technology and intelligent design. Each bar is not only made to be delicious, but also to be uniform, practical, and recognizable anywhere in the world. So the next time you open a chocolate bar, remember that you're not just eating something sweet. You're tasting the result of centuries of evolution, technical expertise, and human passion to create something truly special. After watching this documentary, a real question arises: is industrial chocolate still chocolate, or just a scientific product designed to appeal to the brain rather than the palate? Some call it a technological feat, others a perfectly calibrated, artificial flavor. And you, which side are you on? Give us your honest opinion in the comments. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content.